Hi, everyone. Yeah, I'm super excited to be here. I will be talking about building a design systems component library. And I don't know if you ever heard, okay, like this then, or everything is hanging. Great start. Come on. Yes. Okay, so maybe you have heard the saying, you can't make everyone happy, you are not pizza. Well, when you build a design system, you actually kind of try. There are so many stakeholders involved, and you want to make everyone happy, and it's not easy, of course. So today I want to talk especially about a component library. So a component library is a part of a design system that translates the concepts that are defined in the design system into code. And when you work on a design system, and especially on a component library, you kind of stand between worlds. So on one side, you have the UX and the design side of things. On the other side, you have the developers and code. And both sides have completely different language, completely different processes, completely different tools. And also, both sides are usually heavily understaffed. So actually, when you come in here, in between these worlds with two understaffed groups of people, that's what you do most of the time, right? The designers wait for developers to implement something so they can see how it looks like, how it behaves. The developers wait for designers to clarify something, to provide a design for something, or to maybe also hand over some corner cases that were not defined in the beginning, or also try out some new ideas. So it's waiting, 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 right? Let's look at the design side of the things first. So who of you are designers here? Oh, wow, it's most of you. Who are developers? Oh, it's actually maybe 2/3 to 1/3. So our designers mostly work with Figma. It's a tool to provide designs, to define them, to exchange them between others, and also to hand over ideas to developers. And they also use Token Studio. It's a plugin for Figma, and it enables you to define and provide tokens. I don't know, who ever heard of design tokens? That's a lot of you. Any developer who ever heard of design tokens? Oh, it's quite few. So, but still, I think it was not all the hands. So let me start with the story. So our company has actually a different background than the first speakers. The whole UX and design system and everything is fairly new to us. So we have some old products, and our designers reviewed one of the old products and realized that there were, I think, over 30 different gray colors involved. And now a lot of you are designers and you're probably, oh my God, what do they do with 30 gray tones, right, in their product? So, and I think it's easy to explain because designers were not really involved in the old product. And for a developer, color doesn't have a lot of meaning, except for maybe, well, green, everything is cool. Red, oh, something went horribly wrong. But if you talk about gray, well, it's gray, you need a separator, you put a gray line in there, you need to emphasize something, so you put a gray box around it. Which color code you take is probably something that looks similar. So all of you probably had experience with such old products that were designed like this, pretty chaotically. So design tokens are a means to have a language and to also provide semantical meaning. And how does it work? Here we have a color code, 22746B. It's a hash code for a color. And well, if I ask around here how you would call this color, I probably get like 20 answers, something between blue, green, and whatever. Well, the official name is actually teal. I don't know how many native speakers are here. I didn't know the word teal before I read this. So the first step with design tokens is, of course, to give colors and also other design elements semantic meaning. You want to be able to talk about it. but the name is not providing a meaning, right? And the name is just giving a name, so we talk about it, but it doesn't tell when to use this color. So let's see how to use this color. So first of all, this color has a semantic meaning for our company. It's our brand color. So first of all, we also can provide a token and say, this is our brand color, meaning we can use it in any use case where we want to, for our company to be recognizable, right? And also, our designers designed that we want to use our brand color as our primary interaction color, meaning if you have an element that you build in your component library and it's interactive, so you can click on it like a button or a checkbox, radio button, whatever, you should probably use this color so the user learns everything that's kind of related to this color is interactive. Yeah, and the next step is actually to go further. And when you start defining elements, you can say, oh, okay, we want to build a primary button. So the main call to action button. Okay, it should be really clear and should have a lot of focus. And okay, let's say we use a token for background that's used, of course, the interaction color. And then you always see this spoiler on the right side, it becomes super easy to theme things. Because during all this chain, at any point, you can exchange stuff. So you can say my interaction color in my main product is a steel color, but if you build some sub-product, or you have a dark theme, you just change the interaction color in this whole connection chain. And the developers who only use the final piece, like this primary background color, don't have to change anything because they just get a new value where they work, and it gets super easy to change stuff. Also, designers can decide, oh, this color is maybe not dark enough, it's not a good contrast, and can change it. But all the products that use the design token, the primary background token, don't have to change anything. That's pretty cool. So let's go to the developer side. Developers, front-end developers, usually write components. It doesn't matter which framework they use. If it's something modern, they write components. We heard some about web components just before. A component is consisting of some structure, which is written in HTML or something that translates into HTML, of style, which is defined by CSS or something that translates into CSS, and behavior that is written in JavaScript or something that translates into JavaScript. Then you have the three parts, you give them a name, and you have a custom HTML tag, right? This is pretty cool, which is not pretty cool if you have a company that has a lot of frameworks. This is our environment. We have Angular, we have React, and we have GWT. Anybody heard of it? This is, yeah, it's ancient. It's a Google Web Toolkit. It's a Java-based framework for front-end development. And we have still, yeah, our older products written with that. And of course, have to support it still. Our modern stuff is written mostly in Angular, and we have some React. So you just heard a talk, which is very convenient for me. What do you do when you have such a situation? You don't want to write each component 3 times, right? And in reality, if you actually write components for specific frameworks, you not only write a component for Angular and React and GWT, you also start writing stuff and supporting stuff for different versions of Angular or for different versions of React. And then you have not only 3 different components that do the same and look the same, then you have maybe 6 or whatever. So it can scale a lot. So not surprising, especially after the last talk, we went for web components. Web components were greatly introduced. Thank you so much. Just one thing I want to add, it's super future-proof. It was already said, it's defined by a World Wide Web Consortium. It's a group of people that works on web standards. And whatever they define will be supported in thousands of years. So there's actually really funny talks about stuff that was defined by them like 30 years ago. Nobody's using it, but you can use it to hack funny things. So you can Google for this. It's quite exciting. So the good thing, if you decide for web components, they are future-proof. And you probably heard, like, every day a new JavaScript framework comes to life. Doesn't matter, web components will be always supported because they're in a standard now. So every browser there is and there to come will support them, meaning every framework that there is and there to come will support them forever. So even if you decide that React or Angular, whatever comes next, is not for you, your web components will still be supported, which is super cool. Yeah, we also had the same decision, of course, between going native and or lit element or stencil. Native is not a decision, don't do it. But lit element and stencil was a big discussion for us. We went actually for stencil because we loved the great tool support, and we didn't have the resources to build everything ourselves, so we wanted to get a lot out of the box. And also Stencil is providing the wrappers that were mentioned before automatically. So if you have Angular and React, Stencil will parse you automatically wrappers for your components. So your React and Angular products can actually use the components as if they were written natively as Angular or React component, which is super cool and also helps your teams to be motivated to use the design system actually. But even more important than the decision itself is actually documenting it. You might be surprised, but when working with design systems, it's even more important than in every other product, but it's always important to document your architectural decisions. So why? Why it's especially important for a design system? Because you have so many stakeholders. So many stakeholders, people everywhere in the company, independent of their roles, will be interested in what you're doing, how you made decisions, why did you decide like this? Did you consider option C or option B, and why did you decide for A in the end? And they will ask again and again and again. It doesn't matter how much you communicate, it's just reality. So having some written documentation is super helpful, and it's not that much work actually. So there are templates for ADRs that are super short. You basically say, well, this is my context. So for example, in my company, most people are working with Angular, but we have also teams with other technologies. Then you say what options you looked at, what pros and cons were considered, what you decided for, and what consequences it has for the future. And then you're done. It's like half a page with some bullet points. It's really not much work to do, but you will be so glad that you have this stuff in written, that the next time a question comes, you can hand it over. The issue, of course, how do you get people to read documentation? So we wrote quite a few of those, because I don't know if you heard this saying, but architecture is everything that is difficult to change later. So if you need to decide, do I document this decision or not? Is it difficult to change later? Then you should document it. Otherwise, it's something fluid and the documentation will be old before you change it 3 times. So how do you get people to read it? We actually made a little competition. We asked our teammates or people in our community, hey, one of those files, one of these architecture decision records was written with ChatGPT. Can you guess which one? It's so exciting how many people will contribute and read documentation if you make a game out of it. It's cool. Actually, nobody guessed right. Kudos to ChatGPT. But people read documentation, which is really cool. And you want people to read the documentation, you want them to get involved early in the process so they can ask their questions. Because it might sound like it's annoying if people ask, why did you do this? Why did you consider this? Did you consider also that? But it can be also quite helpful because they will point things to you didn't think about maybe, or you thought about it and then you can explain it to them. But it's always helpful to get into this discussion, even if it's tiresome also sometimes. But that's when written documentation helps you. Yeah, let's go back to components. So this is a screenshot, a few screenshots actually from a text box. So yeah, we're talking about like a little box which has a label and you write something into it. I know the designers between you probably are not surprised. That's a Figma documentation. Other people might, because usually if you're not heavily involved in front-end development, or even if you are, but you're not a designer, you might be surprised how actually complicated a text box is. No, it's not just a box where you can write inside. It has a state, or it has a lot of states, so you can look at it. So it has a default state. You can hover over it with your mouse, and it has a hover state. You can focus it, so when you click on it or jump there with a keyboard, then it can be disabled. It can be in a runner state. It can accept different inputs, or something like currency or numbers or passwords, and you have to treat everything differently, and you have to validate everything differently, and it's so much work. And it's not only that. So here is actually a page from World Wide Web Consortium. I mentioned them before. These are the people who define web standards. And they also have definitions for every standard web element, how it's to be used with keyboard. And actually, radio button, so this is this little dot you can click, like, are you male, female, diverse, anything else I don't want to share? Sounds super easy, but when you ask some people, how do you use this with a keyboard? Most people won't guess it. Some might, but nobody will be sure. So this is not a lot of knowledge involved. So we have a lot of complexity here, right? We have the super complex elements, text box. We have a lot of knowledge that needs to be there for developers to actually correctly implement keyboard interaction. I mean, it's natively there if you use like native elements, but sometimes you do things with them with a framework, and these things stop to work. And if you're not really know about those issues, you might break things for some of your users really quickly. Oh, so what do you do? Hopefully you don't have to handle it yourself. So our recommendation, and we actually talked with other companies, other teams who also work on design systems. Some wrote all their components themselves. It's a lot of work, and if you talk to these teams, you hear a lot that they still struggle with basics, even after years of development. So if you want to write your components from scratch yourself, like basic stuff like buttons, you need a dedicated team. You need a lot of resources, a lot of time. If you don't have this, which is probably true for most companies, we at least wouldn't recommend doing this. So try to rely on an existing library that does a lot of maintenance for you, that does a lot of testing for you, has a huge community. If there's a bug, it will be fixed quickly. So you actually, with your team, can focus on business values. Then you can focus on components that are really specific for your use case, for your corporate identity, for whatever you're doing in your products, and needs to be recognizable, and don't have to handle single text boxes or something like a datetime picker. And yeah, what did we do? We decided for material design. Most of you are probably familiar with material design. It's the design system from Google. Most of you probably had experience with Material 2. It was the former version of the design system. It had a lot of implementations, so it had a lot of component libraries available in Angular and React and Vue, whatever framework you're using. So a lot of developers also have experience with it. But recently, I think a few years ago, Google started working on Material Design 3, the next version, and they did some decisions differently. Of course, they changed the look because it needs to be fresh, of course, but also they changed how they build things. One of it is now they provide a web component library. Ta-ta, it's actually great timing for us. When we started thinking about what to use underneath, actually the component library was still beta and was still in the early stage, and we could actually visit it every week and saw a lot of progress going on there. It was really, really cool. And for us, of course, it's perfect because we want to have a web component library for all the frameworks in our company. And we get a lot of components out of the box from Google, maintained and tested, and can just make them look like ours. So I don't know if you had experience with previous version of Material, with Material 2. Styling, it was not fun. So yeah, because they provided some means like theming, so you could define your own color palette. You could do a little twitching in there, but if you wanted to go further, if you wanted it to really look like yours, you had to tweak in CSS. And CSS was not considered a public interface. So you know what happens if it's not a public interface, it can break all the time. So when a new version comes, things break, you have to change a lot. So it was quite painful, actually. But Material 3 is new and fresh, and I didn't give you the introduction about design tokens for nothing. They use design tokens, which is really cool because now we have a public interface. It will be compatible, backwards compatible in future, and you can style everything. They provide you super fine granular tokens for everything. So you can change the distance between text and your border, and if the borders are round or edgy, whatever. You can style everything. Super cool. So, but tokens are not, so tokens are by definition technology free. That means if you as a designer want to provide a token system, you need to do it not in a specific technology. That's how the definition goes, because it needs to be independent of technology. So Token Studio itself, this plugin for Figma, if you export them, you get JSON. JSON is a format most people can work with, but JSON is obviously not CSS. And if you remember our slide before, what we need in code is actually CSS in the end. So how do we go there? Well, we have the designers, of course, they can look at our design tokens, they can look at materials design tokens, and then they can start plugging them into each other, right? Say this token goes to this token goes to this token, but we're still in the area of non-technology, right? We cannot use it in development. So our developers would need to take these definitions and translate them into CSS so we can actually use them. And you remember the slide before, there's a lot of iterations going on. So when designers start to work on design tokens, so much change will come because it's super fine granular. So you realize that this token doesn't work in that context. And with this button, you need some something specific. Maybe you need a new token, or maybe you can reuse another token. A lot of iteration going on. And you remember, we want to be pizza. We want to make everyone happy. So our task here is to marry design and tech and to have a really happy marriage. How do we get there? With the help of robots. Well, if you didn't guess that, I'm a developer. I'm not a designer, so automation to the rescue. How do we get there? So let's start with Token Studio. I told you Token Studio is a place where designers work in Figma. They define their tokens. And Token Studio allows you to open a pull request in the GitHub repository. So for who of you are not technical, GitHub basically is a tool where you have your code inside as developer, and a pull request is basically a change set with changes. So you say, I want to propose these changes into the project. So now we get this JSON definition directly as a pull request into our repository, which is already pretty cool, but it's still not CSS, right? So what do? We need CSS. Well, of course, we built some automation. So Token Studio, the tool, is also providing an NPM package, so tools that you can use to take this JSON and to parse it into CSS, which is exactly what we want, right? So we built some little automations with GitHub Actions that whenever the pull request is opened and there's a change in JSON in the specific files, we call our automations that translates this tokens into CSS variables, and then that's an auto commit. So we're still in the context of the pull request. We get the JSON, we get the CSS automatically committed. But now, if you're a developer, you probably start to get really, really nervous. So you had actually changes that affect your code, right? Done by a designer and some automation. You probably won't sleep well. Nothing against designers, but still, it's a little creepy, right? So what do you do if you get nervous as a developer? You need to test things, right? So you can sleep well. How do you test designs? I mean, if a designer changes a token that affects color, I mean, you could compare to the state before, but you don't see his intention, right? So you cannot completely automatically test it, but what you can do is provide your designer a visual preview. So they see if their token changes affect the components in a way they expected, or if there's something strange happened. So we use Storybook. You probably know Storybook. It's a tool that actually gives you a list of your components that you defined, and you can click on them. It's code, right? It's code that's being executed, so you can change some configurations. You can click on them, you can pull them and do whatever. So you actually interact with actual real components. And here, we do this directly in the pull request. So you see a pull request my colleague opened. First of all, you see the commit that was done by the automation from Token Studio. So we get the JSON. Then the next step, the automation starts running. It sees, oh, there's a change in tokens. Let's do some CSS parsing and then commit the changes. Okay, we have CSS. And then the next automation step starts and says, oh, we have changes in our tokens. We should provide a preview link to our designer and everybody else interested. And it's happening all inside of the pull request. Not the developer is involved. And the designer then can click on this preview. Here's a screenshot of Storybook, and then can just look at the components, click through them, and see if their ideas and their changes affected all the components, also the future components. So we have an area for future components that are not publicized yet to everybody, but we work on them. So actually, for example, material theming can be done by a designer without developer involvement, because they can plug the tokens into each other without any involvement of a single developer and iterate until they're happy. No waiting involved. So cool. Yeah, and as I said, they can iterate and do changes. So a lot of changes happening in the project, of course, and you want to track this change, and you want also to release a package when you're happy with your changes, right? There we also use automation. So we use here a tool called Release Please, great name. It basically tracks all the changes, all the code changes in the project, takes the description of the change and puts them together into one file. And it also understands what the changes are about, if it's a bug, if it's a feature, if it's some chore. For example, you fixed a typo, you don't want it in your change log, right? So it shouldn't be there. And this tool understands what changes happened in your project, gathers them automatically as they go. So you don't have to go back and see what happened, because it's automatically gathered for you, and also counts the number up, so the version number. And whenever you say, now I'm happy, I want to release a new version of our library, you can just merge the pull requests. The automation will provide you with an NPM package. So everybody in your company can just have a new version. So if they use GitHub, probably use the PandaBot. It's basically a tool that tracks versions into your project. So they actually automatically get a ping. Hey, there's a new version of the component library. Do you want to upgrade? And they click yes, and basically are done with that. And also this tool provides, as I said before, a pretty and structured and automatically gathered change log, which is also very useful, especially, you remember, we have a lot of stakeholders and they want to know what happened. And now they can read it up super easily. Yeah, how do we do this? With semantic commits. You remember in the beginning of the talk, we were talking about colors and how they have little meaning for developers, but a lot of meaning for designers. It's similar with commits. A commit is basically a description of the change sets that you're doing, and developer can write there any text. So, of course, the automation cannot guess what's the intention when you put a comment there. So you need to use semantic commits, meaning commits that describe the intention. And you can quite easily do it. So you have just to have a specific form in your commit message, and then the tool can understand what's going on. And it's another thing, you don't want developers to go there and check commit messages from anybody who contributes, which is designers and a lot of other developers. So yes, of course, we automated it. So we have a check that actually checks this commit message and gives you an error message if it's not okay, if there's a typo maybe, and it cannot guess the meaning. And then you can fix it easily in your pull request, and then it's ready to be merged. Are we pizza? I don't think we are there yet. So we are in a super early stage, but we at least broke the waiting game. We enabled our designers to be super independent, so they're absolutely enabled to work and iterate alone without the need to wait for developers. And developers are also able to focus on their core work and don't have to read up about keyboard interaction for like basic elements. They don't have to check commit messages. They don't have to closely review changes that the designer did. So this, we save a lot of time, right? And that's what you want to do if you have a little team or even team that actually has other work to do and does it on the side, which is the case for us. So we try to automate as much as possible to make as many people as happy as possible. And as I said, we are still in quite early stage, so we are still learning a lot. And one reason why I'm here, I also want to get into talking with you, which we will do in a minute. So I'm super happy to hear about what you learned in your projects, what worked for you, what didn't work for you, and yeah, to gather some experience. And that's it. Thank you very much.